The second derivative and concavity. Consider the graph of y is x squared minus 2x squared minus 5x plus 6, shown below. There's an oblique point of inflection here at 0.67, 2.07. I believe that this one's exactly 2/3, but we just rounded it. The curve is concave down from negative infinity, essentially, through to the oblique point of inflection. The curve is concave up from the oblique point of inflection through to, essentially, infinity. So this section of the curve just here, around to the oblique point of inflection, that's concave down, and from the oblique point of inflection onwards, that's concave up. Consider the results of example 2 of the last section. We've just done example 2. We found negative 16 was the value of the second derivative just here. Negative 10 here, negative 4 there, 2 here, 8 here, and 14 just here. The curve is concave down to the left of the point of inflection and concave up to the right of the point of inflection. It's easy to remember which one is up. It's U-shaped. d2y dx squared is negative at the x values where the curve is concave down. d2y dx squared is positive at the x values where the curve is concave up. d2y dx squared is 0 when the curve is neither concave up nor concave down, i.e. at that point of inflection. Note, be careful with this, the second derivative is always 0 at a point of inflection, but we cannot use it to identify a horizontal point of inflection. And that does mean a horizontal point of inflection. We'll look at that later, as it is possible for the second derivative to be 0 at a maximum or a minimum. And we'll talk about that later when we look at the second derivative test.